A bit of a story about how all of this started. I'll give you a 10-second overview. Back a long, long time ago, I was a student here, and I was working with David on our first Seneca Mozilla project together. I was very proud at the end of that. I spent a semester and a half, maybe 2 semesters, working on a project. We're writing some code that ended up in Mozilla. I thought that was incredible back in those days. As a student, to me, that was something I couldn't believe. That pales in comparison to what these guys have done. They worked not on one project, they worked on a major project with a bunch of components that the project relies on. It took years. The reception has been phenomenal. People all over the world, as soon as it was released, were using it, were praising it. It was all over the media. It was very, very exciting stuff. I know I watched them do the work. I don't know what they've been doing. I kind of have some ideas, but I know it's amazing stuff. I know that their experience is something that everyone can look up to, even though they are still students. Kieran's just about graduated. So give him a hand, please, and let him go.
So, thank you very much, especially for coming here today at 9:30 a.m. I'm Gideon Thomas, and this is Kieran Sedgwick. We're part of the Mozilla team at CDOT, and we're here today to really tell you a story about how we built Thimble, this cool new app that we have, and a journey through 2 million lines of open source code that we went through to accomplish this feat. We also would like to cover a few lessons that we learned through this process and impart that knowledge onto you. So before we get started, let's start with a little bit of context. For those of you who don't know, what is Thimble? Well, let's take a look at a short video explaining what that is. Okay, so as you can see here, this is what Thimble is. It's basically an editor with a real file system, an editor, a preview, and you have all your files here that you would basically want for a web project, including images, as well as style sheets, and your actual HTML. So you can even add other files through this neat little interface that we have out there. And what this allows us to do is change code in the editor and see live results on the right-hand side immediately. Now, of course, please bear with us. We don't actually have any audio for this, so I'm improvising here. It also it guides you through the process of writing code. So as you saw there, it gives you documentation as you type code to help you understand what you're actually typing. And another cool new feature is that it allows you to change the color very easily using a color picker, for example, and it includes a lot of other really neat features, including a tutorial. So some projects have this tutorial.html file, and what that means is you get a tutorial of exactly what you can do in your project, including what line number you should change, what you should change it to, and what that actually means. So there you can see again, you can change your images that you have, and basically refer to anything in your file system or that's on the web. It also allows you to change to a mobile preview and give your project a really neat name. And the best part of all is that you can publish this onto the web, share it with your friends, share it with people, and voice your ideas through web technology. And another neat feature is that you can allow the people who view this project to remix it, which means they can take this project, get the code for it, and modify it as they need it, and create their own vision of what they imagine the project to be. So that's basically what Thimble is. But we do want you to note something very important. Our presentation isn't focused on what Thimble is capable of or what isn't capable of. What we focus on is the actual experience of using different open source technologies to build any product. So why should you care about our presentation? And more importantly, why should you care about using open source technologies in developing your projects? Well, it really boils down to saving money and saving time. Saving money in terms of development costs, saving money in terms of maintenance costs throughout the entire project, and saving time in terms of the time required to actually write all that code. So, if you're not convinced yet, let's take a look at this. I know it's early, and I myself am like semi-conscious right now, so with that in mind, how many of you, by a show of hands, know about these companies? Thank you. I was expecting a much different reaction. So, hopefully, you should know that the point here is that all these companies use open source technologies in a lot of their products, a lot of the products that you use. Why? That's the question, really. And, well, it's quite simple. All of them are businesses. And as a business, they need to make more money and spend as little as possible. The way they do this is by leveraging open source technologies to reduce significantly their development costs. One other reason that they would want to use open source technologies is because it promotes innovation in the company itself. And a great example of this is Bootstrap, which is Twitter's most popular open source contribution that has completely changed the way that we do front-end web development. So I'd like to take a quick detour right now to express a sentiment that is echoed throughout our presentation. Linus Torvalds is best known as a great developer, the father of Linux, and also for having a very sharp tongue. So I'd like to quote him on something recently that he said, which was, "I'm a lazy person, which is why I like open source, for other people to do work for me." That's a very powerful message in my mind, because as we go through the presentation, you'll realize that a lot of the code that is part of Thimble, we did not write ourselves. In fact, we used other people's code. And the best part of all is we didn't pay them for this. We got it all for free. So let's get started, because our journey began with an idea that existed because of this cool new desktop editor called Adobe Brackets, which was mainly used to develop other web technologies. And what that meant was we got an idea of what would happen if we took this desktop editor to make web technologies and put it on the web. Well, that sort of begs the question, why brackets? Well, there are a couple of points to remember here. Firstly, not only is it used to code web technologies, it's also built using web technologies. So it's built as a desktop app using HTML, CSS, JavaScript, the most basic web technologies, and probably the most powerful web technologies out there. What this meant was that the chances of us taking this, putting it into a browser, and it just working, were a lot higher than using some other code that was written in some other language. Of course, there are the other points where it was completely open source, so that meant we could take the code, modify it, create a new product out of it. And it was also very extensible, so that meant that adding new features to brackets was very easy in terms of code, which was actually a big problem that we had with Thimble initially. The final point is probably the most important point of why we decided to choose brackets. And that's that it had an active developer community. And as you'll see, this is echoed out throughout the presentation over and over again. Brackets had an active developer community, and what this implied was that we were able to leverage the experts on this software for help. Whenever we were stuck on a piece of code, whenever we needed to get something working, we could ask them for help, and they would either contribute code or actually just guide us in the right direction. And this was a really cool thing to have. So our journey began with an idea of taking brackets, and there was also an opportunity to improve an existing product that was also called Thimble. And as you can see here, this is basically what it looked like. It was an editor, a preview, type something here, it will tell you what's wrong, and if there isn't something wrong, it'll immediately show you live results in the preview. It was pretty neat, but as great as it was, there were some issues. Firstly, adding new features to Thimble was very, very difficult for one primary reason, and that was that this code base was built in a really, really short span of time, really quickly to get something done and to make our users happy. And that brings up an important point about Thimble, because this was only initially targeted at new developers of web technologies, so complete beginners to the web. Another point is that because of the way we built Thimble in a really quick manner, adding new features was not even planned for. So the development of Thimble sort of stalled, and it was really hard to extend it beyond its capabilities. So we thought, here's an opportunity. What if we took Thimble and made it easily updatable? What if we were able to respond to user requests for new features quickly, and what if we could expand our user base by allowing Thimble to allow us to easily add new features that would cater to advanced users a lot more easily in Thimble. So let's go head first into the first 490,000 lines of code off the bat. Before I go further, however, I'd like to inform you that as we do this presentation, we're going to be counting the number of lines of code that's actually in this project with you guys using a very simple tally system. So as our proof of concept, we took brackets, put it into a browser, and immediately we already had leveraged 461,000 lines of code. I mean, that's a huge number. We didn't write any of this code, but we still used it in our product. So that's really valuable to us, because that saved us a lot of time, a lot of development costs that we could just cut off from Thimble. But of course, with any software, nothing's ever that simple. You can't just take brackets, put it into the browser, and oh my God, it just works. Fortunately, that didn't happen. So there came our first challenge. We needed files. And the reason we needed files was because initially, the first iteration of Thimble, only worked with one file. So you had your HTML, you could put your CSS and JavaScript, but it all had to be in one file, and you would get your end result on the right. Brackets, however, had a different concept in mind. It worked in terms of projects. And projects, by definition, means multiple files. So we needed a way to make that possible. And what that implied was we needed a file system that could work in a browser. So we searched, and we actually didn't have to search that far, because we found a library called Filer.js. Filer.js was code that we borrowed, and the best part about it was that it was exactly what we needed. It was a file system in a browser. So if we actually add the lines of code that we use from Filer.js, it's another 28,000 lines of code that we didn't write. So a total of 490,000 lines of code we haven't written so far. And Thimble's already halfway through being done. Amazing, isn't it? So after that, we took Filer, added it to brackets, put it in the browser, add a little water, and presto, we have an editor in a browser. Yay. However, there's a small technicality. When we say we really mean David Humphrey, which is the lead project developer on Thimble at CDOT. David had presented this stage of the project already to us and Mozilla in 2013. And his groundwork with Filer.js and his prototype for getting brackets to work in a browser really showed Mozilla and us the real potential of brackets and what it's capable of, and why this would be a great idea to do. And this is what it looked like in the end. We had our file system that was based on Filer, we had brackets, and it was all just working in a browser perfectly. And the best part about this was it was even working in Internet Explorer at this time. It's very important for us. So this brings us to our first lesson. Lesson number 1. Open source opens up new possibilities. And this is very important because the new Thimble was only possible because, firstly, we didn't have to pay for those 490,000 lines of code that we borrowed. The second most important point is that we didn't need to spend the amount of time, which is actually a very significant factor because that writing 490,000 lines of code is not easy. It takes a lot of time to write that, whereas Thimble was done really in not a very long amount of time, certainly not years. So with regards to that, where does that leave us at this point? Well, I hope to rely on Kieran for that to continue this journey. So, Kieran?
Thank you. So, you might have noticed when you saw what brackets was after it was put in a browser that it was missing a few pieces from that initial Thimble animation that you saw. So, our next stage of development was moving towards parity, and this was our next approximately 100,000 lines of code. So, what were we missing? Well, you can see that we have the editor on the left, and you have some user interface pieces, but there is a giant side of the screen is probably the most important feature for the people learning to use the web, which is this live preview. So we needed to add something equivalent to that. And this was our second challenge, because this wasn't easy. But luckily, we did have a place to start. Adobe had done some experiments towards this sort of potential. And we took another experiment made by David Humphrey called NoHost and combined these two together, pulled out a few pieces that broke the browser, and in the process learned Adobe's code. And this was all it took in the end, I don't know, which makes it sound a lot easier than it was, to provide that same functionality. And this highlighted a lesson for us, which was that when you choose to adopt an open source library into your own product, it means that you have to invest time in learning their code, especially if you want to make any significant changes. For us, this time investment was maybe a few months, a year, but certainly less than it would have taken us to develop this from scratch, which is a theme that you'll see. So now we had the live preview working, but that wasn't quite enough. To get brackets ready for the prime time, we also needed to remove a few features that were part of the original product that we no longer needed, like the UI that came with brackets, status bars, extensions that came with brackets that bloated it and made it slower to download, pieces like this. And in the end, we ended up with a working preview with multi-file projects and on a small team with just probably a few months of work at this point. And this is what it ended up looking like. So you can see that we're steadily moving towards that Thimble feel, where we have the code on the left and the preview on the right, and we're almost there. So by the time all was said and done, at this point in development, we probably removed more code than we'd added, and this left our totals at something more like this. And I want to draw your attention to that center column and the number 866. That's how many lines of code, approximately, we had written to accomplish what you just saw. Think about that for a second. 461,000 lines of code for brackets, nearly 30,000 lines of code for filer, a couple more thousand lines of code for the no-host library that we used, and we wrote a paltry 1,000 to get as far as we were. This is something special. On a rotating team of 4 to 5 developers, not bad. So, we had this interface, and now we needed to bring it up to parity. You could see that it wasn't quite the same. It was just brackets that we'd touched so far. And the old Thimble had a couple of important features that we've already explained, like the ability to save your projects and to publish and share them. And so before we could really say that brackets was ready to be used, it had to allow for these features. So we were left with a choice. We could either create this new Thimble from scratch, or we could adapt the old Thimble codebase. And so we had to weigh these options. If we did keep the old Thimble, it would mean that we didn't have to write as much code, which is a big deal. We hate reinventing the wheel, so this was a big appeal. And it would also mean tearing code out rather than adding code in, removing the old editor, removing the old preview, and stuffing brackets in its place. And as I already mentioned, we wouldn't want to resolve the problems that we had already painstakingly solved in our previous cycle when we developed the initial Thimble. And finally, that touches on the fact that there was a whole community of developers who had gone into actually building that first iteration. And if we stuck to the old code base, we might have been able to leverage their experience as well. But on the downside, it meant that we had to wade into code that hadn't been touched in a long time, relearn it, and there was a final piece to that puzzle, which was that Thimble was a part of a bigger initiative called WebMaker, and that meant that it was interconnected tightly coupled to a bunch of other applications and services that were slowly being phased out and sunsetted. And that meant that developing this locally was going to be a bit of a nightmare for the first little while. I'll cut the tension. We chose to keep the old Thimble and to revamp it. And the main reason was we didn't have time to waste. We didn't have the resources to go about building something new, and we knew the technology it was built on. The Express.js stack is very popular, and this was the technology that was underlying Thimble. And switching to something new, which we might have considered, that is to say, switching to a new technology to build out this server, we might have considered if we were starting from scratch, and that would have meant everybody on the team learning at once, whereas with the experience that we had, at least some of the developers knew the technology that we were working with the old code base. And again, the old contributors were something we could probably leverage if we decided to keep the code. So if we check in again and we add the lines of code used in the Express framework, which by the way is very, very popular. In the Node.js world, which is what the server-side technology we use to build this product in the first place, Express is very, very popular. If we throw that in and we also throw in the line count of Thimble when we adopted it, then you can see that our total is steadily going up, and it's dropped a bit. The number hasn't changed too much because we tore code out of brackets as well as adding some stuff in. So we're getting there. And now we had to face the third challenge, which was to add those publishing features back in. So old Thimble had a publishing solution, but that publishing solution was being deprecated, along with the rest of the WebMaker suite. So this was something we had to rebuild. And that meant we had a choice about what tech we wanted to use. And when we built it, we knew that this would involve teaching Thimble how to use this new service. So this is always a challenge for developers. Do you pick the shiny new whiz-bang thing that all the cool kids are playing with? Or do you stick to something more familiar, maybe a little more pedestrian, but predictable, something that people know how to work with? And so we weighed these options. If we kept to what was known, then we would have to learn a little less, which is nice, because that would mean more time coding features. We would have more access to contributors, because they would already know the technology and have that foundation that is needed to even get involved. On the other hand, if we went to something new, it could perhaps be more specialized, more apt for this particular use case. And there is one other factor that has nothing to do with open source, and that is that we had access to a brilliant developer who promised us that if we used this new technology, she could build it for us in a week, the basic version of this. And so we took her up on that. And we're going to skip ahead, and we're going to add a few of the other major libraries and our final line counts of how much code we actually ended up writing approximately. So this represents the main dependencies, third-party libraries that we leveraged, the old Thimble code base that we revamped, and all of the code that we wrote to create what you saw in that video at the beginning for 16,000 lines of code. So we've developed a product that acts like old Thimble did, but has a boatload of new features, and we've accomplished all of our goals with that paltry sum of code written. For those of you who like math, the ratio of code that we wrote, or sorry, code that we leveraged or borrowed to code that we wrote is about 33 to 1. That's about 3% of the total code base that we ended up using was code of ours. Bit of a mind blow, but it came at a cost. And this is our third lesson, and it's a pretty important one, and that is that when you leverage open source tech, it is a double-edged sword, because third-party libraries range from new and immature to old and well-maintained. And in our case, some of the worst issues that we faced was documentation just not existing, or being completely inaccurate, or confusing and misleading. Lack of support, if contributors weren't actively developing the projects anymore, meant that there was no one to turn to ask questions. And features we sometimes assumed would exist in these libraries that we were leveraging just didn't, or were incomplete. So in the end, what this actually meant was that, and this is more in the spirit of open source, we had to contribute back to fill in those gaps. And this meant more lines of code from a business standpoint. So, just to touch back on what we've learned so far, open source presents new opportunities and also means that you might have to learn a code base you didn't before if you wrote it yourself. And in the end, when you run into problems, you can't always rely on the products you're leveraging to have the solutions. You might actually have to get in there and get your hands dirty to write those pieces yourself. So you might have noticed, again, if you're into math, that our math doesn't really add up to 2 million yet. Well, our estimates were based, the ones at least in the video or the presentation that you've seen so far, on the main libraries that we used. But those libraries relied on even more open source libraries. So there's this giant pool. And so we're going to include a few more of the most important ones in this next slide. And we're going to do a cost projection with some caveats, but hold on to your seats. So while you absorb those staggeringly large numbers, I'll explain what you're actually looking at. So these are estimations of how much it would cost if a single developer was paid a salary of $55,000 a year to develop each of these products. It's based on the Kokomo model, which is typically most accurate when it's used with a large, mature code base to estimate the cost. And it's also not used too often with the distributed nature of open source technology. It's usually meant for standardized commercial development. But even if we cut that number down by 90%, you're looking at approximately $10 million of code we didn't write. Even if you cut it down further than that, you're looking at $1 million if you go to just 1% of this estimate, which is a standard. This is phenomenal and really demonstrates how much value you can rip out of the open source community and eventually give back with all of the updates that you put in. So this kind of leads us to the end of the presentation, and we'd like to know if you have any questions about what you've seen today. Thank you. Starting on that side.
How much of the code that you contributed back was accepted?
Quite a bit, actually. We, especially on the bracket side, we ended up identifying a number of problems that were either filed upstream that they fixed for us or that they were very interested in taking, because they kind of wanted to go in the direction that we were heading, with the live preview in the same pane and pieces similar to that. So they were very interested in finding ways to use what we'd done.
What about other things like Files.js possibly?
So Filer.js, we glazed over the truth a bit here, which was that it was built by a Mozilla contributor and David Humphrey, and this library, although it wasn't built for brackets, which is why we included it as a separate third-party library, was something that we were patching constantly. So it got updated a lot because of our work. Yeah.
So where do those lines live when you're running this program? How many live in the browser and how many live in Node.js, or where does this run?
You want to take that one?
Sure. So where do these lines of code live? So Node.js is the platform we use to run Thimble. And so Node.js itself, we haven't touched any of that code. It's just the platform we use. It's open source code, but it's over 2 million lines of code. The lines that we wrote lives in Thimble, which is the server that we created that runs on Node.js. So we wrote about, how much, 11,000 lines of code, approximately, and most of that, let's say about half of that runs on the server side on top of Node.js. The other half actually runs in your browser, which is what you actually got to see, the front end part of it, the cool looking green UI that you saw. That was the other half of the 11,000 lines of code. And all the other things, Express.js, a lot of that was server side, Happy.js, a lot of that was again server side. These were all frameworks that were built on top of Node.js. Brackets, the actual 490,000 lines of code, is actually again in your browser.
And just an interesting technical note, at less or around a megabyte, the entire application, which is kind of a cool tidbit.
Really, yeah. So actually more than 500,000 lines of code, compressed down to 1 megabyte. It actually is really impressive that we could do that. So yeah, the brackets lives in your browser. Half of Thimble lives in your browser. So in terms of a percentage of how much code that we wrote lives in your browser, it's still about only 2% or about 3%. The rest of the code, because brackets uses most of that code, contributes to most of that percentage.
Good. Yes?
You guys had a really interesting estimate of like how much it would cost for a single developer, all that. How much did it cost for you guys as developers, or how much would it cost for you guys as developers, given the amount of time that you?
So that's a difficult question to answer because we don't run the books, but there was at least one full-time developer for the majority of the development cycle. I think we tried to average it last night, and we came up to about 3 or 4 full-time developers for the space of, say, 8 months. So whatever that cost would equate to.
I guess maybe the question was, Kieran, if you use that same Kokomo model or whatever it's called for your number of lines of code, what would that be?
Well, it's a tricky business. If we were to try and apply that model, it wouldn't actually be accurate. This is one of the things that we discovered, is that it is best used with the bigger code bases, which is why we stuck to those more significant meaty ones. This is a question that's very interesting. It's something that if we had a little more time, we would have explored more, because that is the other half of the business piece. Yeah. Yes?
So I'm coming from this from an instructor perspective. That's essentially like I'm an instructor here at the college. I'm just curious because the learning that you've got, if we had to build a course around that, how would that fit in with the existing cycles of 14-week semesters? And there are so many moving parts. But the reality is what you face. By the way, it's a great project. I really like it. But the reality is that that's what development has become. So just your thoughts on how you speak to that. Because you all are students here, so you have the 14-week cycle. But then a lot of this would have gone on over years in a sense.
So the question is, if we were to have developed something like this as part of school, how
Would you create a course around something like this?
around the development cycle?
No, just the learning that you had right now, because there is the learning of getting all these parts. You have to discover which libraries
Okay.
to go out and search out for. So I don't know. Like I'm just.
I can give a shot at answering that because that is actually a very complex question. And I'm going to say, personally, we had to do something very similar in a course currently being taught at Seneca. It's called the Open Source Development course, taught by David Humphrey again. And he goes through this procedure and he explains to us how the software development cycle is riddled with changes. You are going to change your approach, your code base, whatever it is, throughout the entire process. How do you balance that out? By looking at existing code bases and contributing a small amount of code to that to make it your own. So all these things are actually covered in that course. And what you end up with is a great product. Now, how to actually combine all these different open source technologies, that's a little harder. I would say that would take a bit of experience with working with real projects. So coming up with an idea, probably exactly the way we started. Come up with an idea, look for an opportunity. If we can motivate students to do that, which again, it's hard in a course. They're constrained by time, they're constrained by other courses. So that can be hard, but if you can actually motivate them to start with those two, the rest sort of just falls in, especially with the way we've learned the open source course. And they sort of figure it out that, okay, I have this idea, how do I materialize this? Well, I don't want to write that much code because this idea, it might be $1 million idea, it might be this really great innovative thing, but it's really, really hard to do. Okay, as you may have experienced, a student's first approach is, okay, let me Google this this question. And most of them will do that. I have this idea, I have this opportunity, let me Google if someone's already solved this. Or let me Google if someone has already solved part of this. And let me use that code and then build upon that. So developing a course from that strategy is really hard to fit into 14 weeks because it took us 8 months to do this. And I would say it's more important to embed all those concepts of how this process occurs and encourage them to learn this on their own.
Yeah, if I was to add just a little bit to that, I'd say that the cycle of open source development is very similar no matter what you're doing, no matter the scope you're looking at. I mean, obviously, the bigger the project and the bigger the goal, the more times you have to go through it. But the cycle of research, find the library, figure out if it does what you want, patch it, research, find the library, do it, et cetera, that is something that can be taught and that Dave is very good at teaching. And it is something that I think you could probably even make an entire stream out of. If not that I'm qualified, but that would be my opinion. Yes?
Well, I obviously know you guys. But I was interested to build on what Mark's asking. I'm interested to know, because I don't know the answer to this. I've taught a lot of students who don't achieve what you've achieved. So I'm interested to know what it is about a project like this, because you didn't come up with this project. It was handed to you, and it wasn't always fun. I mean, you're here at the end of it and it's successful, but there was a lot of pain and just software is hard. What motivated you in all of the different things that you did? What kept you coming back to it? And if you could extrapolate, what are the likely things that we could do with other students that would motivate them to want to do the kinds of cycles you're talking about? What kept you from giving up? What made you come back and do more? What inspired you? What motivated you? What made you excited in something like this?
Do you want to answer the second part of this question?
Sure.
Okay. Okay. Well, at least least add my 2 cents here. In all honesty, it's a lot of it had to do with the experience of failure. You start with, like, we worked on other projects before, and like we're not hiding this. We didn't really, they weren't real successes. They were great projects, great ideas, great opportunities, but they amounted to nothing in the end. And what that sort of does is it sort of builds up a fire in you to just prove that wrong, that no, you're like every time you do this, you are not gonna fail because other people have done this. So if I were to answer one of your questions, which is how do you motivate students, probably show them other people have done this. So showing them Thimble, great example of how they can try something. It is also important to tell them that yes, it's likely that they would also fail. But again, it's the old saying, like, keep on trying and trying hard, trying again, or whatever it is. But yes, basically that. Like, I would say that the passion is developed by experiencing the bad side of it first, and then it sort of makes the success a lot sweeter.
So you have something to prove.
Exactly.
Okay.
And that's what brought me back to the project over and over again. Maybe you can share something.
Yeah, as Gideon was talking, I was thinking about it, and in my case, it really motivated me to see that these skills that I was learning, programming and the reasoning and design and all of this, actually had a context now. There was something real world to fit it into. It wasn't just some contrived number cruncher to spit dates out backwards in a data structures course. It was actually something that not only produced an end result, whether it was a wild success or just something to show off as a technical achievement, but it also meant that I knew that I created something people would use. There was a particular moment, and this isn't a code contribution, but it was close, where I had been developing a piece of this, and I ran into a particular challenge, and it was a nightmare. No one had the answer to this. I crawled the internet and the deepest depths of Stack Overflow, and I still couldn't find an answer. And so I hacked my way around it. I posted that solution on GitHub, and I woke up a few weeks later, bleary-eyed, and looked at my computer, and saw that I had notifications on GitHub from people I'd never seen before. And it was people going, thank you. Thank you. And so I had this feeling of I'm involved in something bigger than me, and I'm leaving an imprint, I'm having an impact. And the combination of having a skill set that felt like it was real and whole, because I knew how to use version control, and I knew code review, and I had actually learned the language through experience, with this ability to give something real to other people that they valued, made all of the failures and all of the tremendous frustration, because it is frustrating to do open source development sometimes, worth it. I actually managed to get that back, and then it became addictive. My metaphor is you only learn to love spicy food by eating a crap load of spicy food. And eventually the burn, you just come to love it. And in the end, that was the final straw. I'm addicted now.
I'm going to disagree with the last thing you said. I
haven't eaten enough of it, I think. Any other questions? That was a great question. Yes?
I'm interested in the point at which you made a decision between 2 or 3 alternatives. You put it up on a slide as if it was, here it is, here it is. We looked at it, we talked about it. 20 minutes later, we said we're going to do this. So you took down a path, obviously, at a certain point. So how did you take that path? I mean, it wasn't as clear as a slideshow. And the second one is, did you ever have thoughts about, we took this path, but what about if we'd taken the other one? Would it have been better, different, or?
So I'll take the first part of that. It's always a tough decision, and you have to weigh a bunch of options. And we had a couple of turning points and a couple of frank discussions with each other in the team to see sort of where we should take it. But we were relying on the experience of not just our group, but on the experience of this entire pool of developers that had been working on open source projects for a long, long time. And we relied on that. And so we made our decision at one point, for whichever reason it was, and just sort of had to stick the path.
Also, to your point about, did we ever think about what if? As Kieran mentioned, that open source software development can be quite frustrating sometimes, and that will happen regardless of which path we choose. So, based on our experience, whenever we actually did encounter a frustrating point while developing, while going through that path that we chose, we always did think, but what if we actually did it that way? We would never have had this problem. And there are both pros and cons to that line of thought. I mean, the most obvious con being, okay, it's too late to go back now and try and see what would happen. And the most important, I would say the most important con would be that we made this decision not based on blind faith. We backed it up with a couple of facts or with whatever, but this decision was not made blindly. So I would say that once we made that decision, we were pretty strongly stuck by it. We strongly stuck by it. And even though we wondered occasionally, what if, we still said, okay, this was still the right approach because of all these reasons that we chose it in the first place.
And I can add just one tiny little piece to that, which is sometimes we did have to try the other way. We would try the first way and realize we were wrong, have it explode in our face, or be like, this problem is just too big, and we'd end up having to go back anyway. So it's kind of an illusionary choice sometimes anyway. I think we're about close to the end here, so we'll probably leave it there. You've been great. Thank you for coming out at the crack of 9:30 to see us.